Here's our Chapter 4 review. We've got a couple of proofs to go through here. We're going to take our given statements, WN bisects SWO. That gives us, I'm going to mark up this diagram. So we've got these angles we know are going to be congruent. We've got SW congruent to WO. And we need to prove segment SN is congruent to segment NO. So let's take our statements. WN bisects angle SWO and segment SW congruent to segment WO. Of course, those are given. Always start with what's given. Well, let's do the bisecting first. The consequence of that is that angle SWN is now congruent to angle OWN, and that's by the definition of a bisector. Okay, that gives us angle congruence. How about segment WN congruent to itself? Segment WN, that's this shared side. Whoops, all three works. That's that shared side there. That's the reflexive property. Tells us that that segment is congruent to itself. So now that's enough to prove that triangle SWN is congruent to triangle OW. And let's make sure we have our order of notation correct. So triangle SWN here. So segment SW should be congruent to segment OW. SW, OW. Okay, we got it. WN is in the correct position. So that's our proof for the congruent segments. That's by side angle side. We've got congruent triangles. Well, with congruent triangles, what we're looking for is segment SN congruent to segment ON, or rather segment NO. Segment ON, segment NO, same segment, and that's by the CP-CTC. Okay, another example here. Let's take what's given. QR parallel to TS. Okay, so this side parallel to this side. Segment QR is also congruent to segment TS. All right. And we're going to try to prove QT parallel to RS. So let's take the QR parallel to TS is given, and then QR congruent to TS. Our given statements. Okay, well, that tells us, let's see, we've got a parallel line, we've got those two parallel lines cut by a transversal. So let's focus in on angle QRT, that's this angle here. There it is. That is going to be congruent to angle STR, which is this angle right here. Why are those two angles congruent? Because they are alternate interior angles. And we know that QR and TS are parallel. Those are given. Well, how about segment TR congruent to itself? Here's our shared side that's congruent. That's reflexive is the reason. Reflexive. So now we have triangle QRT is congruent to triangle STR, and we know that by side angle side. So QR and ST are congruent based on what's given. the angles alternate interior, and then the shared side is reflexive. So we've got triangle congruence. Well, if we have triangle congruence, we now know that angles QTR, which I'll pick a different color here. Here's QTR. That is congruent to angle SRT based on the triangle congruence. Well, angle SRT is right here. So that's the CTC tells us that. Angle QTR congruent to angle SRT. Well, that's nice because those are now alternate interior angles. If we look at these two lines being cut by this transversal, that's all we need to show that QT is parallel to RS, and that's alternate interior angles, converse theorem. All right, one last example. We've got triangle ABE as isosceles with base BE. Okay, isosceles tells us that two sides are congruent. The base BE is not one of the congruent sides, so AB has to be congruent to AE. All right, we've got that. Side BD, that's this segment here, segment BD is congruent to segment CE. These two segments are congruent, okay? And then angle B is congruent to angle E. So let's see if we can put this together in a proof to show that triangle ABC is congruent to triangle AED. So triangle AB is isosceles with base BE. Of course, we always start out with our congruence, or our given statements. So here's what we know from what's given. Always start out with what's given. Now, what I had explained and showed on the diagram is that AB, side length, side AB, segment AB is congruent to segment AE, and that's by the definition of an isosceles triangle, as I explained before. So we have those segments are congruent. Now, we also know that BC is congruent to DE. Now, why are those segments congruent? Well, what we'd seen before is, based on this congruence, BD, which is made up of segments BC and CD, that's congruent to and equal to segment CE. Well, CE is made up of CD plus DE. That's CE. So we know the congruence. Well, here's what we're focusing in on right here. Based on the equality, we can subtract CD from both sides, and we end up with BC equaling DE. Well, BC equals DE means their segments are congruent, and that's by the segment subtraction postulate. Segment addition postulate. Segment subtraction postulate. So, okay, so now we've got side AB is congruent to side AE. We know that angles B and E are congruent, and now we just showed angle BC is congruent to angle DE. So that's enough for triangle ABC to be congruent to triangle AED. And we know that by side angle side.